I'm going to talk about serving data from browsers. I'm Ben. I'm Benjamin Benman on Twitter. I work for a company called Pusher. We do like real-time notifications and stuff, and like so quite similar to Twilio actually. We kind of have some similar kind of cool stuff. One of the things I've done at work last week was I built this thing which is a button. So you can press it and you can hook that up to do whatever you want. So we had people like building like someone wrote a Morse code tweet machine. So you could basically type in Morse code on this button and then it would like tweet out on some account, which is kind of cool. We called it the internet button, like because it looks like the internet off the IT crowd, which is kind of cool. I'm down from Oxford today, where I help run an event called JS Oxford. So, oh, brilliant! Hey Joe, how's it going? Cool. Joe's from JS Oxford. Represent. So, yep, we have meetups every few months. One of the things so I'm really bad at keeping secrets, and this is one of the things that I'm supposed to be keeping secret at the moment. We're organizing a conference for October, so that's going to be a kind of one-day community conference up in Oxford, which will be cool. So, that's cool. I am talking about serving data from browsers. And a bit of a spoiler, this is going to end up saying that servers workers are kind of cool, which is what Phil's just told us for half an hour. Thanks, Phil. Thanks for that. That was really handy. So I'm not actually going to talk about kind of as broadly or as well as what Phil just did, but I'm going to talk about one specific use case that you might use service workers for. And actually, I'm not actually going to talk about just purely service workers. I'm going to talk about things that you can use in service workers, but also elsewhere. And it's just basically a deep dive into a particular project that I found quite interesting to work on. So the thing I was working on is how you take your data that you're collecting and you're pushing up into some kind of web API and how you can get that back down and in your hands kind of thing. And so the goal that we're going to do is we're going to look at, as a user, I want to have my data as a CSV document. So that's just a kind of like tangible end goal that you can aim towards. The two data sets that I'm going to talk about are Last.fm and Runkeeper. So I think everyone knows what Last.fm is, and Runkeeper is this kind of run tracker thing. So you put on your phone and it gives you GPS traces. And I'm going to switch between those two because I built these two projects that export that data in the way that I'm going to go through just now. And one of them does Last.fm, and that uses like standard, pretty standard web technology, and the Runkeeper CSD one uses service workers. So, just a bit of an introduction to the problem. So, we're going to start with Runkeeper and just think about how we get to our data. So our goal is to get a CSV document of our kind of activities or our coordinates as we're running through. So let's go through how we might do that. So first of all, we might go to runkeeper.com and try and download it, right? So a lot of services have some kind of page that you can put in some dates and press the export button. And then you get a zip file with all this data in, which is cool, right? Like, so I've got these 4 activities that were in that range and a couple of CSV documents. And so this is cool. And the good things about it is that we've done it, right? Like, we've got our data downloaded. And that's what we were trying to do. And another thing is, like, once we've got that data downloaded, it does work offline. Like, essentially, we can plug it into Excel if we want. It's not a kind of online resource. That's kind of tenuous. The bad things, this signifies bad, is we don't have any control over that format, right? So we got that down in GPX files. I'm not really sure where that is, but we want it as CSV files, or maybe we want it as geo-JSON files. And we don't have control over how that's exported. That's all to do with Runkeeper and how they've chosen to export it. That functionality might change or disappear as well. So for instance, I think in the Last.fm newest site launch, you've lost the ability to export your data, which is kind of a bit sucky. But you can use an online browser-based tool to do it. Cool, so that's what we've got with downloading it straight from the site. Attempt number 2, we might want to write a script, okay? So we write a bash script that goes to Runkeeper, we plug in a token, and we can download our scripts. And this uses a really cool library code, or a tool called JQ, which allows you to pull data out of JSON documents. And doing this, you can kind of pull out the URLs for all your activities and then plonk them into a file. This is up on a GitHub gist, so other people can kind of share it, download it, run it themselves, which is cool. So this is great. We've got choices over format. We've got the raw data, so we can cut it however we want using our tools. It's shareable. You can go on GitHub. You can put up your own kind of ways of tweaking it, which is great. It's also offline in a way. Like as soon as you started downloading that data, it's there on your hard drive. You can kind of like play around with it and stuff like that. And even if you only downloaded half your activities, that's fine. The bad thing is this is like super inaccessible in a way. If you think of all the people that could benefit by having their data in a CSV file, and you think of the people who can run a bash script and know how to install JQ and know what a curl command is or whatever, then that's a kind of tiny little proportion. So yeah, scripts, although they're cool and useful, are kind of inaccessible. Which brings us to attempt 3. So attempt 3, we make a web service to do this. So we make our own thing that, luckily, both those services have APIs, so we can make a web service that goes to those APIs, pulls it down, and gathers it together. So that might look something like this, where you sign in with Runkeeper. In the background, it downloads all your activities. And then after a little while, you can come back and download your data in the same way as you do on the Runkeeper site, apart from we've implemented it ourselves using that API. And this is super cool. We've got it accessible. We've got those format options from before. It, again, works offline because you've downloaded it once. But if you're trying to download a different cut of it, then you've got to be back online. The bad things about this is that's actually kind of hard to make, right? Like it's not like just a tiny little hack project. You've got to think about how to deal with hundreds of concurrent requests, how to kind of queue stuff up, how to notify users when stuff's done. It's difficult, right? And also, there's a potential for you having to store sensitive data on your back end. So, for instance, with running data, you can find out where people live, where they're running to, which is which is sensitive stuff. So you're having to kind of deal with that issue by storing it somewhere that they can download it. And also, as an end user, you've got to wait for that processing. Like before, when we've had that bash script, as soon as stuff's streaming down, you can start tweaking it and looking into it. Whereas in this scenario, you've got to come back in like a few minutes, and then you can download it and see what it's like. Which brings us to attempt 4, which is to go client-side, right? Like, so this is obviously where I was going, because we're JS London. So in that first, that web service we've got, your browser would hit the web service, which would then go to Runkeeper and then download all the stuff. Whereas another option we've got is for our browser to authenticate with our service and get the details it needs to go to Runkeeper itself and pull down the data into the browser itself. So this is what this might look like, and what it does look like. So we've got this page that's downloaded 175 activities here, and you can see you can download these different cuts of it down here. So that's what you can do by bringing it client side, and we'll get into more details of how to do this. Cool. So the good stuff about this is that the data is stored locally. You don't have any of those issues with storing them on your server. It's available instantly. As activities are downloading, you're able to download cuts of that data. So once you've downloaded 2 or 3 activities, you can download a summary of those 3 activities. You don't have to wait for it all to be compiled and aggregated on the server. It doesn't work everywhere, or it might break sometimes, but that's cool. Right, okay, so we're not going to cover that in too much depth. Right, the things we're going to cover is what we need to do in the browser to make this happen, right? So the first step is we're going to request the data from our source, either Runkeeper or Last.fm. And we're going to take that data and we're going to process it, so convert those JSON into CSV document, for example. And then we're going to serve it to a user. So we're going to look at some of the options we can do with that. And for this, we're going to use Last.fm. So just as a kind of like nice simple example, how you might, I take it everyone's heard of Last.fm. It's like a music storage thing. So everything you listen to gets pumped up to Last.fm. Right, first one, requesting. So what we're using here is like the fetch API, and we're just wrapping around that to make an easy way of hitting the Last.fm API. So we've got a kind of hard-coded key in here, and this is just a simpler way to kind of wrap our request to that. And what I quite like about, so this is something, we're using ES 2015 here, and we're using the arrow functions. And I really like how this makes it really easy to kind of compose promises, and it just, like, stuff like this turns really kind of weirdly clean. So yeah, that's cool. So that's our kind of abstraction over the API. So our next task is to get all the requests that we need to fulfill a user's data set. So for here, we're pulling out, what are we doing? We're pulling out the first page of their data. We're finding out the number of pages, and then we're generating a number of requests for each page. And that will kind of resolve to something like this. So we're getting so this is all the pages of data that relate to my username. So I can then download those. And then we just need to make them, right? So to get the data for a user, we just call that function and then submit all those to Last.fm, like through our API wrapper that we made before. So pretty straightforward. You have to do something with like throttle the requests, but that's a bit kind of boring, so I'm not going into it. But it's also, yeah, you can work it out. Okay, so that's us. What we've got is we've got all our requests, we've got our data in this in these JSON objects. So what we're going to do is we're going to process them, and what we're trying to do here is turn it from JSON to CSV. Okay. What you can do, you can go to so there's a lot of different libraries that do this kind of CSV generating, and it's hard. It's like a kind of difficult thing to do completely right. So you want to use something like this, or you can just hack one together, which is what I've done here. And so this is like just generates. It's really in a hacky way generates CSV rows. It kind of cuts out all the speech commas out of stuff. And yeah, so you can see at the bottom, you basically pass in some information, what keys you want to pull out, and then it will give you a CSV row, which is handy. So yeah, so now we've got this process function, so we can pull out that data. We can map all these requesters through that. So basically, instead of getting the raw JSON files back, we're getting this CSV string. And that's cool. So we've got that data in our browser. The next part is to serve it. One way of doing this is data URIs. So that's a URL of a form of data and then a media type, so you can serve any kind of content through this. So for instance, has everyone heard of data URIs? Cool, a few people. So what you can do is you can put this in your browser, and it will serve that as if it's content that it's viewing. So you can actually kind of type this in, and you'll get an HTML document with "Hello World" in it. And we can do this for CSV documents. So if you link to this, then that will automatically just spark a download in your browser. So you'll get that kind of like 2-line CSV document with ABC123 in it here. And so we can now put this all together. So we're generating generating that data, passing it through our Last.fm thing, and then we can then so we've got this data coming through, and then we're converting it all to CSV, and this is entirely it. So we're basically creating an element with that link, and then setting the href to that data URI. And so if a user clicks on that, it's cool. But we've got a bit of a problem with that slide, which is our CSV variable here is like a huge, humongous string, which kind of feels a bit ugly, and especially like Last.fm data. So I've got, I think, 190 different rows in my CSV document, so this becomes huge, right? And then passing it to data URI, you're creating a new one that's even longer because you're doing some stuff. So the solution to this is to use blobs. So this is a kind of a way of storing strings of data in a mutable way that they're not in your kind of like JavaScript heap anymore. So it's a lot more efficient and for like creating files and stuff like that. It's kind of like a file. And the way you create this is like you initialize a new blob with this array of strings or typed arrays or whatever with some extra options in. So we can take this and basically when we're putting on a document here, this URL, create object URL, takes that blob and then gives a short URL that references that blog. So as soon as you visit that URL in your browser, you're basically viewing that generated data. And you can do some like really nuts things with this. And one of them you can do is you can set that as being a large CSV object, and then when the user links to that, then it will download. So that's a bit more of an efficient way of doing it and kind of nice. So once again, we can use this. So we can convert all our string concatenation to be blob concatenation, and suddenly it's like super nicer. And at the bottom here, you've got this text CSV, so that gives a MIME type for the browser to know to download it straight off and what to do with it. And then here, we change that data URI to create object URL, and it all works exactly the same, which is nice. So what we've gone over there is like this request, process, and serve. These three things, so we're requesting it by expanding all the requests we need to pull down data for a user, processing it by passing that data through our API wrapper, and then serving it using data URIs and blobs. So that works, and that's all up online, and it's actually been kind of weirdly popular because it's a kind of generative thing. Like, so a lot of people, I get a lot of users ask me questions about it. I think it's because it's not a final, I'm not showing people graphs, I'm showing them this is your data, you can do your own things with it. So I've seen some people doing some really interesting stuff with that, which is good. So this is where we get onto service workers. So the cool stuff like that all works, and that's totally useful and good. But as soon as you navigate away from that page, your blob URLs are lost, which is a good thing. And actually, you don't have a persistent URL, so you can't point static scripts to kind of plot that URL or bring it into a different script somewhere. And also, it doesn't work offline. You've got to have an active connection to Last.fm every time you want to regenerate that data. Which is where service workers come in. Yay! Which are great. And yeah, IndexedDB, as someone asked before, I think it was you. Yeah, so I only use IndexedDB because it works quite well for this kind of when you're pulling down a lot of data and trying to cut it in particular ways. But equally, you can use a cache for it if you wanted. Yeah. So our process here has come a little bit more, we put in a few kind of like server workery parts, which is first of all saving it into our database, and then processing it and caching it when we do that processing, and then serving, and we'll see why that's useful. So now we're switching to Runkeeper Data. So our first up, we've got that request, which is exactly the same as the front end. So as you pointed out, we're on HTTPS now. That's necessary to run this service worker because we're running it in there. And we've got, because Runkeeper is authenticated, we've got a Node app on the back end which does some OAuth stuff with Runkeeper, I think. So saving it, which is a new part. So what we're doing is, this is partly the same with the fetch, apart from we're shoving it into this IndexedDB instance. And the thing, I really like using Dexy, which is a kind of really minimal wrapper around IndexedDB and makes it, kind of promisifies it and makes it quite easy to do these kind of migrations between different versions. So here we've created a store called activities on a database called Runkeeper. And that activities has got an index of URI. And what we're storing is we're storing just, essentially we're chucking JSON objects at it. And in this case, it happens that our JSON objects have a URI key on it, so that acts as our kind of primary key. And so you can add as many different keys on that activities URL, that activities store, and you're able to query by them. And the Dexy, has anyone used Dexy before? No, cool. You should check out, it's really nice. So then we're just like putting it into DexE, and because DexE goes around promises, it works really well with all this kind of fetch, promisey kind of stuff that I was saying before. So this is what that, when you open up your inspector in Chrome, you get this, you can see the data, so you can query it briefly, and you can see that URI over here. That's the one that we're able to kind of make calls on at the moment. So basically, I want to iterate through those URIs and pull out all the data later on. Right, okay, so which brings us to the processing part, where what we're doing is we've got our data and we want to process through it and convert it into a CSV document. So again, this has got similar parts. So what we're doing is where you can see var data equals new blob, that's exactly the same code as before. We're creating a blob of that CSV row, and we're concatenating that together. And so, but then instead of making those, going through those requests and doing it there, we're actually iterating through a collection of activities from that database. So it's logically kind of the same, but it's got this different kind of wrapping around it. And this allows us to, instead of going through requests, do it all locally and offline, and we'll work in a service worker. And the other thing to notice is, as well as the blob, we're returning a response with that blob in it. And that's taking that blob and making it into a response like something you'd get from a fetch request, and that you can shove into your cache and stuff. Which brings us to caching, which Phil touched on a lot better than I have with this example. But basically, this is an example that I use in the Runkeeper Data one, which what it does is it tries to use a cache version, and if it can't do that, then it will populate the cache with, so it will fire off a call to it and populate the cache. So this way you can kind of pass different kind of listeners in under different routes, and it will be cached the next time a user comes to it. Which brings us to serve. So serving is a new one, and this is all about the service worker, right? So what we've got is this add event listener, which you implemented, and we're catching anything that ends with summary.csv, and then we're calling that respond with the event and that summary responder thing, which I showed much before. And so what this is doing is, like, when that URL gets caught, it will send a CSV summary and it will cache that nicely and stuff, which is cool. And the part that you totally win, that I'm getting, that basically this is all about, is in that same way, you can add these different routes. So here we've got summary CSV and we've got distances CSV. And those will be caught by different listeners and hit exactly the same database. So although, because of the service worker and because of the way we've architected this, there's no longer, we're not having to re-request any data from anywhere. As soon as you've kind of got that summary CSV file available, you've got all your kind of distances and paths. And another one that's quite interesting down here is our geo.json response. So we can format it in drastically different ways. So there we've kind of, rather than longitude, latitude paths, we've got geo-JSON files. So we're able to format it in that way. And we've got that choice that we wanted at the very beginning of how we own our data. And then down the bottom, I've got a binary path response, which is like a really kind of hardcore typed array thing, which you can load straight into 3JS. And so you're able to kind of have that kind of control over what you build. Which is cool. And a kind of happy coincidence of this is the fact that it all works offline, right? Like, so suddenly, once you've downloaded that data once, you can come back to it with shaky network connection and you've got it all there. It's like super fast. Like, so one of the nice things with IndexedDB is that it can take a little while to warm up kind of thing. And so by creating that from a service worker, you've got that instantly. Like, you don't have to, like, you're requesting the service worker, which has already kind of got that database open. So it gets super fast, as well as the caching, which is great. And it's super great, which is I kind of touched on as well. Right, okay, so I don't know if I've got time for like a couple of demos of this. Okay, cool. I'll show you like, So just to show that it actually is a thing and not just a bunch of slides, what we can do is, I don't know how to exit this. Right, okay, so this is that page so this is running locally. But what this is doing is this is populating, so it's already populated because it's in the cache, but this is populating that IndexedDB instance. And so this is actually hitting it not through a service worker, but through a standard worker, but it's using the exact same code. And now down the bottom, we've got this distances CSV, and that gives us a raw kind of CSV document that you can't see, but it's real. Oh, it's not that. Okay, cool. So, and you've got these different cuts of the data. So you can see there, I think these are, that first one, that was generating it. The next time we hit it, it'll be faster. So that's the kind of how you can organize the data and allow it to be downloaded. I'll just show you quickly. Where are we? I was supposed to link into this. This is what we've done. Right. So you can see this is us accessing that data. Wait there. Right. So this is us accessing this data through the service worker. And we're pulling that data out, that summary CSV, and we can do that through a regular fetch request. But what's nice about this is that this is using that exact same route to visualize that data. And so it's all cached, it's all nice. And so is this. So this is like the amount around the Earth that I've run. And that's using that same endpoint. So suddenly I can use all these D3 visualizations that I've already got and just apply it to my live data set, and I can make it appropriate to a particular person. And then we've got these different types, these different cuts on the data. So using the exact same backing data, we can see kilometers versus time. And also we've got a lot richer data as well, so we can see all the kind of intra details by loading another path. So this is using two different endpoints as well. As I mentioned, geo-JSON, so this is using the service worker to access the data in a kind of geo-JSON format, so suddenly we can do some stuff with it. We can plot it using D3. This is every route that I've run. And you can't really see those points the differences very well, so this clusters it together and then groups them together, so you can kind of see the places that I run, which is kind of cool. And this is the main one, which is Oxford. So we're basically using this service worker to view this data in a very different way. In the way that we drew that kind of standard graph before, we're able to draw in this rich D3 environment thing. As I mentioned, we've got binary data we can shove straight into 3JS. So this is 3JS, which is using WebGL, and I think it's plotting 110 or around 110,000 different points. So that's Brighton, and this is kind of to get more of a feel of what this data is like and explore it. And service workers make that quite easy, which is kind of nice. But yeah, so there's a lot more there, and you can kind of see the amount of data that I've got here. And WebGL is like the best way of visualizing this data here. Cool, I think that's... Cool. So that's all up on GitHub. You can check it out and stuff. It's also online if you want to download your data, see what you can do with it. That would be good. Profit. I don't know what I mean by that, but it seems like a good thing to have on slides. So thanks a lot. Cheers. Cool.